Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so Thursday we talked about radicals and multiplying radicals together. So just like everything else now, where it used to be multiplication and division were like those more difficult operations, multiplication and division with radicals is just easier. You just multiply them together and it becomes one big radical. So radical 2 times radical 3 is just radical 6, okay? So we'll learn later that radical 6 divided by radical 3 is just radical 6 divided by 3, which is just radical 2. Okay, so now we're going to add radicals. So just like fractions, just like terms and things like that, the adding radicals, you have to be a little bit more, picky. You can only add like radicals. So for example, 4 radical 2 minus 5 radical 2 plus 12 radical 2. We'll just treat it like terms. They're all radical 2 terms. So 4 minus 5 is -1 plus 12 is 11 radical 2. So far, so good? So you can treat that radical, since you can't do anything with it anyway, because you can't take the square root of 2, then just leave it as kind of like a variable. So this is kind of like 4x minus 5x plus 12x. Okay? All right, so there's really not too much else to this, but obviously if you have different radicals, you can only add similar radicals together. So here's example 2. 4 radical 3 plus 3 radical 5 minus 6 radical 3. So let's write a simplified expression.
Attention, teachers and students. Attention, teachers and students. It appears that the boys are still unable to use the boys' restroom appropriately. We are still finding that boys are urinating all over the restroom. They are also throwing spitballs, wads of toilet paper in your restroom. If this happens again, boys' bathrooms will be locked, and you will need to sign in and sign out using the restroom downstairs. Again, if this happens again, boys' bathrooms will be locked. Thank you.
If you guys have any inside information.
I just want to say, I think he's the smartest person in this building.
Why?
I mean, like, he's peeing on a urine. That's one. Bro, that's epic. Like, what I'm just saying, like, dude, this kid is insane.
It's intelligence.
It's like, it's like
Yeah.
blurred out version.
So we need to have like a pee patrol or something. Get like not a paw patrol.
They put a camera in there. Like,
No,
I might ask someone.
that's illegal. But there are cameras outside, so we could have like a pee patrol, like to go inspect the bathroom after everyone goes in. I'd volunteer. A couple years ago, I wanted to catch somebody who was, I don't know, I don't know if they were on their phone, they couldn't aim, they were distracted, but it's not that small of a target, you know, you can hit the target. But, you know, I've had years of practice. So what's a simplified expression here? What's a better way to say this? So treat it like variables. What should I say? If you weren't detailed, yes, that would be the answer. But be detailed. It's not 2. What is it? -2. All right. So that cute little mark that you put in front of things is a big deal, because you're not only wrong, but you're the opposite, literally, of right. Okay. So you could say -2 radical 3 plus 3 radical 5. It doesn't matter which one goes first. So whenever there's a negative added to a positive, I like to write it like this. But either answer is right, okay? So let's do one more and then we'll move on to the next concept here in within the same chapter. See if you can do this on your paper. Just more of the same. It's hard to complicate this concept. Hey, Cheyenne, Zan, Audrey. Can you guys, we need to plan a time to refilm something again, not refilm, but film another scene. So we have to coordinate like the clothes that you wore when you were in the shot there. So do you remember what clothes you wore? Because if not, I can send you a clip of what you were wearing. Yeah, something like that. But I can send you a little clip to show you what you were wearing.
Yeah, I need.
So don't message you. I'll message you or something. But probably have to plan a time where we can steal you guys again.
Yeah, just because in yearbook we're kind of getting down to the crunch time. We need to finish the book.
Yeah, that's okay. We won't need. It won't be for a little bit.
Yeah.
So
Is it, I don't know how to say this. I wasn't even here. Like, I mean, I was, but like,
it's
not physically
radical.
here. Like, I
Yeah.
saw, but
What'd you get?
should I say it out loud?
Sure.
Okay, I got 8 radical 3.
8 radical 3. And then what?
Oh, that's it. I thought you just kind of.
Oh, okay. So you can only combine the radical 3's with other radical 3's. So anyone else got an answer? What do you got, Eliana?
-5 radical 2 plus 13 radical.
Good job. Okay, so these are just -5 radical 2, and then 5 plus 8 is 13 of those radical 3's. So whenever you have, remember, like 5x, that's just 5 x's. So when you say, I had 5 hamburgers, that means it was 5 times hamburger, okay? So whenever you have a number in front of a word or a letter, that's just multiplication. So this is just 8 radical 3's. So imagine these little radical 3's all in a little, I don't know, pig pen. I don't know. They're all like moving around, okay? So you got 8 of them, and then you got 5 of them. So that's literally 8 of those, plus 5 of those is 3 of those, okay? Then you have negative radical 2's that, I guess the radical 3's ate the radical 2's because they're negative. But anyway, let's move on. Okay, so you guys good with this? So basically you just complicated it, overcomplicated it. Just like variables, you have to stop when there's no longer any variables you can combine. Same thing with radicals. You have to stop here, even though you want to go more, but you can't because these are different radicals, okay? Now, technically, you could get an estimation because you can try to take the square root of 3, but you'll get an irrational number, right? A decimal that goes on forever and doesn't repeat. So you'd have to get a rounded estimation there and a rounded estimation there, approximation. So you would get like, yeah, something, but it wouldn't, but this is the more exact way to say it, okay? All right, moving on. The next part in this chapter is weighted average. So weighted average, we've already talked a little bit about this, but this is like what I do at the end of every semester. Well, what Schoology does for me, if it's working, is it weights your average. It weights your homework a certain weight. It weights your tests a certain weight, your participation. And there is an attendance category, but you guys don't fall into that. So basically, the categories that you do fall in, and we weight those. And it all evens out in the end with people at home and people here. But so weighted average. So let's say that within the test scores, each test had a certain weight. I don't do that in my class, but some people have tests that are worth more than other tests. Okay. So for example, if you were to just take test scores by themselves, test scores are 60, 71, and 91, and I want to know my grade, and they're all worth the same, then what do? How do you find the average?
Add all of them. and
Yeah,
divide by
just add them up and divide by 3. Okay, so then you get 74, which kind of makes sense. That was a doozy, but that kind of helped that out. So if you meet halfway in between 60 and 90, that's like 75. But then that one wasn't quite 75, so it brought it down a little bit to 74. So you can kind of see where it's weighted, not weighted, but see where it kind of goes, the average. But let's say that these test scores were worth more than the other. So let's say that this guy was worth twice as much as the other two. So how do I calculate the average of that? If this is worth twice as much as the other two, how do I find the average of those test scores? Any ideas?
Could you just add 91 twice?
Yes. And you would, so it's like you took 4 tests instead of 3 tests. Okay. So this is worth more. So if I said this is worth twice as much, then I would say 60 plus 71 plus 91 plus another 91 all divided by this time 4. Then that's different. What is that? 182, 242, 313 divided by 4 is still a 70 something, but let's see if it went up a little bit. 70, is it 8?
78.25.
Okay, so that's good. So at least it went up a little bit. So what if it was worth 3 times as much?
You would add it in 3 times.
Yeah, okay, so the shortcut here is if these are all a certain weight, then you would add it the number of weighted times, or you could just multiply by the weight. So here's the deal. Here's another example. So let's say we've got, let's say the second test was twice as important, was worth twice as much, was twice as important. So we're going to say, word it like that. And then we're going to say third was 4 times as important. Okay, so these are the weights. So we're going to add that second test twice. And we're going to add the third test 4 times. So here's what it looks like. You just add 160, so you don't need to even put that 1 there, plus 2 71s, plus 4 91s. Well, how many tests is that? How many test scores is that? Not how many tests, because there's only 3 tests. But how many test scores are we adding? 1 plus 2 plus 4 is 7. So when you do that, I think that might get us up to a B. Well, let's see here. Then you get 80.86. Okay? So it's really not that complicated. I mean, if you think about it, the weighted score is just how many times you add it. Okay, so you not only add those multiple times, but you have to include another test in your total number of tests or whatever numbers. Okay, you guys want to do one more and then we'll move on? All right. So here's example 5. So let's say we had scores 60, 70, 80, and 90. Let's say the weights of these scores respectively. What do I mean when I say respectively?
Like, respect my brother.
That too.
Approximately.
No, when I say the weights respectively, I mean I'm going to list them in the same order I listed the scores. So when I say, and the weights respectively are 1, 2, 4, and 6. Okay, so I want you to find the weighted average of these test scores.
Those are some pretty low test scores.
Well, hopefully. So this is kind of typical of some classes where, like if you take a test in the beginning, maybe you don't know the material very well, so you get a low grade. So that's why the first few tests aren't weighted that much. But now that you've been in the class and you should know the material more, then they weight the later test more. So this is a pretty typical setup for a class that you may take.
I didn't even see that right.
Or what?
I didn't even see that.
See
All the
what-
numbers on the left.
Oh,
Like,
these you thought these were the scores?
yeah.
All right. So let me know when you get it.
Got it.
What'd you get?
That's 81.53.
Nice. Good job. So you add them all up. Well, you don't add them all up. First, you have to multiply them by their weights. So 160 plus 2 70s plus 4 80s plus 6 90s, all divided by what? Well, all the weights added together.
13.
So 13. So then you get, what was it, Zan? 0.53-ish? Is that what you said? Okay. Okay. That's pretty good. Walked away with a B in this class. That last test really helped getting that up there, right? Does this make sense, guys? And it's not going to be tricky. You can probably read the problem word for word and know where to put it. So this is the formula. So the average is going to be weight 1 times score 1 plus weight 2 times score 2 plus ... all over weight 1 plus weight 2 plus ... Okay? So you just multiply the weight times the score that it goes with, add them all up, divide by the total, the sum of the weights, okay? Because the weights are how many times you count the numbers. All right, so this is 65. This is weighted average and adding radicals.
Wait, can we just write it out like that? Like, do we need to write the answer? Calculate it?
Yeah, you have to calculate that. So, for example, if I had to calculate your grade in math, then let's see, your participation is 10%. Your homework is 30%. And your test grades is 60%, okay? So now I could reduce here. Now bear with me. So instead of out of 100, I could say out of 10. So the weight of your participation is 1. The weight of your homework is 3. And the weight of your test is 6. Does that make sense? So I could take your participation grade and then add that to 3 of your homework grades, right? And then 6 of your test grades and divide it all by 10. You can do it by 100, doesn't hurt. You got a calculator, doesn't matter. And you don't have to physically add your homework grade 30 times. You just multiply 30 times your homework grade, okay? But that's it. All right, let's do 66. Okay, so we are gonna revisit what we talked about on Thursday when we're multiplying radicals and simplifying radicals, okay? So this whole chapter is on simplifying radicals. Okay, so Elkin, this is the one that you had the question with. So we'll make sure it's covered today. Okay, so here's the deal. What's wrong with just saying the square root of 50? Well, you can't take the square root of 50, right? There's no nice number times itself that equals 50. But what's wrong with that? Do you remember what's wrong with that? Anybody?
It can't be square rooted.
It can't be square rooted, but why can't you leave the answer like that?
Because you can simplify it to radical 2, 5 radical 2.
5 radical 2, because there's a square. Now this 50 is not a perfect square, but there is a perfect square hidden inside of there. Now, since you can multiply radicals together to get a big radical, that means you can take them apart, all right? So if there's a radical that can be multiplied that's square rootable, then we need to take it out. So what I would do is something like this. There's another way to do that. I'm going to show you 2 ways, because I realized a couple years ago that some students were not getting this way. So I tried it a different way, and then all these students like, oh, now I get it. So I'm going to try it 2 different ways, okay? So just like factor trees, we can say, okay, what times what equals square root of 50? Now, you have to be a little bit more specific to make this easier. Do you remember the magic question? What do you ask yourself? Well, if it was something like this, what do you ask yourself to reduce it? Well, I think you can reduce this in your head without even asking a question, but what's the question you have to ask yourself here?
What goes into?
Yeah, what goes into both 6 and 8? What can you divide out of both 6 and 8? All right, so that was the magic question for reducing fractions. What's the magic question for reducing radicals? Anyone remember? We talked about it, but officially, what is it, Nathan?
What radicals go into a radical?
Okay, so more, not radical, but yeah, Eliana?
What is the biggest perfect square that goes?
Yes, what is the biggest, underline biggest, perfect square that can be divided out, that goes into blah, blah, blah. Okay, whatever we're dealing with. Okay, so what are some perfect squares? Well, 1 doesn't count, because when you take 1 out of something, it doesn't change it. So we're going to start with 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and it keeps going, right? We can keep going a little bit. 169. What's 14 times 14? You guys know, is it 196? And then 15 times 15 is 225. And then 256. There's also a cool pattern here. I didn't realize this until a few years ago. How do you get from 4 to 9? What do you add?
5,
How do you get from 9 to 16?
7,
How do you get from 16 to 25? 9. How do you get from 25 to 36? 11. Look, add 5, add 7, add 9, add 11, add 13, 15, 17, 19. So what you're doing is you're adding odd numbers. That's it. And the odd numbers go up. So these numbers eventually get really far apart. But it's a pretty cool pattern. I didn't realize that until a few years ago, that it's just odd numbers apart, like increasing odd numbers apart. Okay. So what is the biggest square? What is the biggest one of these numbers that goes into 50? 25. So instead of the square root of 50, we can say the square root of 25 times the square root of 2. So far, so good. And we learned that this is legal because you can multiply two radicals to get one big fat radical. Okay? But what's the square root of 25? So this is 5 times the square root of 2, or just, you don't need the dot there if it's right next to it. Okay? So we accomplished it. We found a perfect square, we took it out, and we simplified what you can simplify. So you can't simplify square root of 50, but you can simplify something inside of square root of 50. Okay? Now, here's the other way. This is the way I do it. Square root of 50 is just the square root of 25 times 2. All right? And then what I do is I pull that out of there, and it becomes 5 times whatever's left in the radical. So that's what I do in my head. When I see the square root of 50 or the square root of like 75, it's kind of a lot for me because I've got dyslexic and dysgraphic tendencies. So what happens is I mix the 5 and the 2 around sometimes, and I say 2 radical 5 instead of 5 radical 2. But the square root of 75, all right, there's a 25 in there. So if take the 25 out, and there's a 5 on the outside, but what's left in there? Oh, it was 25 times 3 to get 75, so 3 is left in the radical. So this could be another way to do it. And this is me writing it out, but usually I just do that in my head. But it's probably safer to just say, okay, what's the biggest square that goes in there? So let's try another one. And I want you to try it one of these ways and see if you can get it. Okay? So let's try this. And we're going to combine some concepts here. What's the square root of 18 plus the square root of 8? Well, first of all, you can't add these radicals together, right? But what you could do is simplify those two radicals. So see if you can simplify the two radicals using one of these two ways. So this is like two problems of this. And then once you're done with doing that with both terms, then see if you can combine them together. See if you end up with like radicals.
Okay, I don't know for sure if this is right, but this is supposed to be 2.
Okay.
I said 2.
Oh, okay, so there's one less of those, so it'd just be radical 2, radical 2, radical 2.
Oh.
Okay, and this is the way that's the way Saxon, did you look in the book at what Saxon said, how to do it, or no? Okay, so Saxon likes to just do it all to prime numbers, and I think that's actually confusing, yes. Yep, that's it, good job. Yeah, the number on the outside isn't quite right. Not 7. Where's your? Oh, okay. So this can be simplified.
Oh.
Yeah, you better go before it's locked.
Are they doing that? They do not do
So
that, right?
you can add these two together. Oh yeah, there it is. I didn't see that. So you got radical 9 times radical 2. So that, yeah, that, not plus, but multiplying. Right. And
They're all
then,
multiplied? Or are these?
well, this, when you simplify a radical, radical 18 is radical 9 times radical 2. And then you can simplify that radical 9 to a 3, right? Because the square root of 9 is 3. There you go. Good job. Got it. All right, so let's do this together. What'd you get, Eliana? Five radical 2? Good. Okay, so Audrey, walk me through this.
I'm so confused though.
I know, that's why I want you to walk me through it.
That should make
Okay.
14.
No,
So for the 18, I did radical 9 times radical 2.
Perfect.
And then for 18, I did radical 4 times radical 2.
Okay, and you can just write them like that. That's the beauty of it. You can just write them right next to each other.
And then I added the radical 2's together.
Okay, so you got radical, so but then that's fine. You can, so you get radical 9 plus radical 4 all times radical 2. But that overcomplicates it. So let's simplify this first. What can I simplify here? What's a better way to say that? What's the square root of 9?
3.
Yeah, so don't forget what radical actually means is taking the square root. Okay, sometimes we get caught up in the symbol and we forget what it actually means. Oh, you can take the square root of 9. So radical 9 is 3. So this is 3 radical 2's plus 2 radical 2's for a total of how many radical 2's, Audrey? 5 radical 2's. You were right. What you did was this. You did kind of a radical 9 plus radical 4 all times radical 2. There's nothing wrong with that. But I think what you did is you didn't have parentheses and you just added it all together and it got messy and out of control. But I mean, this is still just 3 plus 2, which is 5 radical 2. Okay. Does that feel all right? Did you see what we did, Oaken?
I was here the entire time.
Okay. Yeah. All right, let's try another one. All right, now that you're warmed up, let's do this one. Here we go. Here's example 2. 8 radical 27 minus 3 radical 75. Okay, so there's already something already outside of the radical. So whatever you bring out, you just have to multiply, because this is 8 times whatever this is. So whenever you bring something out, whenever you simplify, you just have to multiply it by 8 because 8's already out there. So let's see if you can do this.
Just do it like normal math problem, like what's 8 through 27.
Good. Yeah, but you can't take the square root of 27, unfortunately. You can take the cube root, but not the square root. Let's see. Here. Okay, good. All right, so one step at a time. What do you do first?
Wouldn't you kind of, I guess, simplify both of them?
Yep, so that radical 27, there's a perfect square hidden inside of there. So let's go in and yank it out. So you can rewrite it like that with the little factor tree.
Couldn't you do? Wait. Well, what do you do with the 8?
This 8? Oh, well,
just kind of stay there.
Yep, just leave it there until you can deal with it.
So would it be radical 3 times radical 3 times radical 3?
No, don't do radical 3 times radical 3 times radical 3. Do radical 9, because radical 3 isn't a square, but 9 is. Okay, so radical 9 times radical 3. Okay, because radical 9 is just 3. If you did it that way, that's fine. Radical 3 times radical 3 cancels to a 3. So if you can remember to do it that way, then then more power to you. That's fine.
Wait, no, I have an answer before you start.
Yep, good job.
Yeah, got it. Actually, can you do that?
Anyone else have an answer? Good. Get it? So you multiply 8 times 9, but that's not a 9. What is that? So 9 is very different from the square root of 9.
Yeah.
So the square root of 9 is 3. So you're not multiplying 8 times 9. You can't multiply a number times a radical. But that radical is just 3. So 8 times 3 is 24. Same thing here. Yeah. What do you got? Okay. All right, keep going. Get it?
Not quite yet.
Okay. All right, Elkin, I'm gonna have you walk me through it. Yeah.
What?
So,
Do I have to?
yeah, because it'll click. If you're doing it, it'll click. Okay, so what do you do first?
Turn that radical 27 into 8 radical 9 times radical 3.
Right, so 8, radical 9, radical 3. So far, so good?
Yes, and then
Okay.
you have to do a minus sign, and then turn the. You can just write the 3, yeah, and then the 75. You could do. Could do radical 25 radical.
All right, so if you don't get an A on your next test, then he owes you money. Because he robbed you of your A, because you didn't do it yourself. Robber.
Wouldn't I, Robert?
Okay, so now let's just do order of operations. So what do you do in the next in the order of operations? Well, you do that and you do that. Okay, so now what do I write?
Could you do 8 minus 3? So that would just be 5,
Nope.
right? Or no?
No, before you do subtraction, you have to do.
Oh, we have to simplify.
Yep. So this is the step that most people get stumped on. Okay, so what's radical 9?
3 radical 2. No.
So this is
3 radical,
8
Just 3 radical.
times 3 times radical 3. So all I did was take the square root of 9. Okay, minus 3. What's this?
What?
I'm looking at Elkin when I'm asking that.
With that.
So far, so good?
Yeah.
Now, order of operations. Before you subtract, let's multiply. Okay.
So it'd be, what's it called? Times 3 is 24.
Good job, Brad.
What?
Good work. Yep, so that's 24.
So 24 and then 15. And then do we just leave the radicals there?
Well,
And
now
then
that
now
they're the
we-
same radicals,
now
now
we
you
can
can subtract.
Okay, so now it's just, what's it called? 9 radical 3.
That's it. There's your final answer.
Okay.
Okay. So the step where I'm seeing most of you get messed up is either not finding the biggest perfect square. Like for example, you could say this is 15 times 5. But see how radical 15 times radical 5 isn't going to help you reduce it, right? Now, if you keep going, radical 15 is radical 3 times radical 5. So then you have radical 3 times radical 5 times radical 5. Well, radical 5 times radical 5 is just 5, so it's 5 radical 3. So you could get there like that. That's the way Saxon teaches you to do it. I think it's easier to ask that magic question. What is the biggest perfect square that goes into 75? Well, 25. So how do you factor square root of 75? It's the square root of 25 times the square root of 3. Now I always put the perfect square first, because that way, if there's a number out there, I can just multiply them right together. Otherwise, it'd be 3 radical 3 and then a 5 on the other end, and that's confusing. Okay, so when you factor it out, put your biggest perfect square first and then whatever you're left with next. Okay? All right, I'm going to do one more because I think we need it. Here's example 3. This one, here's your hint. This one isn't as satisfying as the other two, but I still want an answer, okay? Square root of 27 minus 3 square root of 18 minus 6 radical 45. Okay, let's simplify this expression as much as we can because we can't do it as much as we did the other two. Okay, so if you get it, you'll get a Flack attack coupon. All right, so Hope and Micah, if you text, remember Alt-V on a Mac, but if you're not on a Mac, here, I'm going to tell you that I'm going to give you something to copy and paste in the chat, okay? So you can copy and paste this. If it'll work, I don't know. So you can use that in your answer. It's very unsatisfying, but at least you're able to reduce the terms.
What is that?
Good.
Wait, I have that too. Almost. Just gotta put it down here, so it's
This should be an 18.
Oh, yeah, no, I have it on here.
Good job. So are you just kind of going through your test too quickly?
I wanna check my word. No, I don't check my word. No, son.
Thanks, dude. I do like simplifying radicals. Something about them just makes it fun to me, but this one isn't quite as satisfying because you're stuck with it. Nice. Feeling better?
Yes.
They're perfect. This one just so that's 6 times 3, right? Good job. Yes, you got it. Yeah. Just have to multiply 6 times 3. Okay, I'm gonna dig in here real quick. Let's see what these guys got. Anything, Micah or Hope? All right, I'll check back in a second. Okay, so I'm going to rewrite radical 27 as radical 9 times radical 3. I'm going to rewrite radical 18 as radical 9 radical 2. And I'm going to rewrite radical 45 as radical 9 radical 5. Well, that's nice. We were able to take the same radical out of everything, but that doesn't help us. What matters is what we're left with. So this is just 3 radical 3 minus 3 times 3 radical 2 minus 6 times 3 radical 5. Okay, so that's 3 radical 3 minus 9 radical 2, minus 18 radical 5. And that's it. Very unsatisfying, but that's it. Okay, does that feel all right? Good. So there's one more part of this. There's just bigger, I mean, you could do this with any number. So the biggest numbers, what I usually look for after like this stuff, I'm like, okay, you lost me. So these numbers, I can't think of all the perfect squares, but I can think of the obvious ones, like the powers of 10, right? So you got 100 as a perfect square, but 1,000 isn't. So it kind of skips a generation. Powers of 10 kind of skip a generation. It's only the even powers that are square rootable, which makes sense. 10 squared is 100. 10 to the third is 1,000, but you can't take the square root of 1,000. But you can take 100 out of that, couldn't you? And reduce it. But 10,000 is a perfect square. So if it has an even number of zeros on the end, then it's square rootable. Okay? So let's do some big ones. So let's take the square root of 50,000. Well, 50,000 is not a perfect square, but there is a perfect square that goes into that. So if I skipped some stuff here, I could say 10,000, not 100,000, but 1,000,000 is a perfect square. And there's a bunch of perfect squares in between that, but you could start with something like that, right? And then obviously if 2 times 2 is 4, 20 times 20 is 400. If 3 times 3 is 9, then 30 times 30 is 900. So any of these numbers with 2 zeros on the end are perfect squares as well. Does that make sense? So any of these numbers, so 400, 900, 1600, 2500, those are all perfect squares too. Okay? So what is the biggest perfect square that goes into 50,000? 10,000. Right. So square root of 10,000 times the square root of 5. So far, so good? What's the square root of 10,000? 100. So just because they're big numbers doesn't mean they're frightening. And I'm not going to give you some random huge number. I'm going to give you a number where it's obvious, where you can find a perfect square. So it's either one of these with a couple zeros on the end, or it's a power of 10. Okay? And even if it is a power of 10, if you just happen to just find the perfect square and not necessarily the biggest perfect square, you can still get it. It just takes multiple steps, kind of like reducing fractions. If you don't divide by the greatest common factor, you're not wrong. It's just going to take you multiple steps. Okay, let's try another one. Let's do the square root of 500,000. Are they playing Jack Sparrow's theme over there? I heard. I heard that. Your brother should learn that on the cello. Jack Sparrow's theme. Okay? It's awesome. Okay, so what is the biggest perfect square that goes into 500,000? So remember, 100,000 isn't a perfect square, but what's the next one you can think of? What? 250,000. Let's see if that works. Square root of 250,000 is, what is that, 50 times 50? It's got 4 zeros on the end, which means I can take the square root of it, and that's the square root of 2. So that's, what is that, 50 radical 2? No, that's 500 radical 2. That's right. Okay. So now let's say that we didn't think of the 50,000 or 250,000. Let's say we just said 10,000, just like we did in the problem before. Look what happens if I did 10,000. So 500,000. So if I do this instead, square root of 10,000, there's nothing wrong with this, times the square root of 50. What's the square root of 10,000? 100, but look at this. What's the square root of 50? right? So then it just takes multiple steps. So this is 100 times 5. So this is 500 radical 2. Same answer, just more steps. But keep in mind, the more steps you make, the more potential mistakes you'll make, okay? So be careful. Try to find that biggest perfect square. Okay. You want to do one more? We'll do one more. One more. Let's do square root of 40 million. What's the square root of 40 million? I think Ethan can do it in his head. Anybody have it? There's multiple ways to do this. So if you're thinking, I don't think I'm doing this right, you might be doing it right. So radical's right if you're just missing a 0. We got it. Well, you not quite. Did you get it?
Let's see. 5 seconds there.
That's all right. If you don't find the biggest perfect square, that's okay. You can whittle it down. Close. You're just missing a 0.
Why on earth would I know what the square root of 5 million is? I have never pondered that in my life.
All right. So, anyone know what the biggest perfect square that goes into 40 million is?
8 million. But it's like 8.
8 million is not a perfect square. 5 million is not a perfect square.
20 million.
So 20 million, remember, if it's got a number with zeros on the end, it's got to be one of those perfect squares. So 2 is not a perfect square, right? 20 is not a perfect square. 200 isn't. So 2 million is not going to be. Okay. What's the biggest one, Nathan?
40,000.
Not 40,000. There's a bigger one.
400,000.
All you have to do is find the next even number of zeros, because there's 7 zeros right now, right? So if you take off a 0 and multiply by 10, 4 million is a perfect square. Look at this. If 4 is a perfect square, that means 4 with an even number of zeros on it is a perfect square. So this is 4 million times the square root of 10, right? Because this is just adding another 0 to get to there, so you just multiply by 10. Well, what's the square root of 40 million? Can you guys do that? Just cut the zeros in half and square root 4.
400.
So 2,000, right? This is 2,000. 2,000 times 2,000 is 4 million. Because remember, when you multiply numbers with zeros on the end, you just add all the zeros together, right? So 2,000 times itself is 4 million. So here's your final answer. Now you could have done this a different way. Where did you start? Ethan and Elkin, what did you guys do?
I went to 20 million.
Okay, that's fine. So 20 million is not a perfect square, but we'll do it anyway. Times radical 2, right?
Yeah.
Okay, well, what's the biggest perfect square in 20 million? What? Oh, yeah. So what's the biggest perfect square in 20 million? Is that where you stopped?
No.
So what's the biggest perfect square that goes into 20 million? Is this where you guys got stuck? Right here? Okay. You got stuck just because there's not well, there is one in there. I mean, you could take out a 4 million, or you could take out not a 10 million, because 10 million has an odd number of zeros. But if I took out a million, then this is just a million. And you could just do it by just taking out powers of 10 times radical, what is that?
20.
So yeah, radical 20, and then you're still times radical 2 here, because that comes down. Well, radical 20, well, this is just 100 or 1,000. This is just radical 4 times radical 5 times radical 2. Well, radical 4 is just 2. So this is 1,000 times 2 times radical 5 times radical 2. So that's 2,000 radical 10, okay, which is the same thing here. Now, this one got confusing because you didn't get a perfect square. Now, don't worry about the 4. Let's try it this way. What if we just did this instead? Because the easiest squares are like 100, 10,000, 1 million, okay? Those are the easiest perfect squares. So I'm going to take 10,000 out of 10 million out of this, not 10 million. Yeah, 10 million out of this. No, 1 million out of that. All times the square root of 40. Okay, what's the square root of a million? 1,000. All right, and then you just have to deal with that. So that's just radical 4 times radical 10, right? So that's 1,000 times 2 times radical 10. So 2,000 radical 10. This is 2 steps instead of like 3 that we had before. But the first step has to be finding a perfect square. If you don't find the biggest perfect square, it's not the end of the world. It's just going to add another step. Okay? So see how you can, the easiest perfect squares to spot are the powers of 10. All right, the even powers of 10. All right, I'm going to give you guys a point. Micah, I'm going to give you a Flack attack point for the other one, but that's it. Any questions? All right, your homework, I think, will give you some practice. If you still have issues with these problems, let me know and we'll figure it out.